Hi there, this is Mr. Thill coming to you with another math video. Today I'm going to continue discussing the properties of multiplication. We previously talked about the commutative property of multiplication and the associative property of multiplication. Today we're going to move into the final one, the distributive property. Now, just a reminder, when we talk about properties of multiplication, those are basically rules that can be applied to any multiplication situation. And to be honest, this is probably the most challenging of the three properties because it's kind of hard to represent it mathematically and have it make sense. But I'm going to be using visuals primarily to kind of show you how it works. Also, to be honest, this is probably the property that I personally use most when doing mathematics. I don't think about it. I don't say, hey, I'm using distributive property. It just kind of happens naturally when I'm calculating things mentally in my head. Now, for the adults in the room, you probably remember distributive property is this. So you would see 3 multiplied by 2 plus 2. And then you would think of it as, you got to distribute your 3 over, you'll end up with 6 plus 6. Your bottom will be 12. That's probably what you think of when you think of distributive property. For third grade purposes, it takes a bit of a different appearance. So I'm going to do my best to explain it mathematically, but also visually. Okay, so let's say we have the problem 4 times 6. Okay, I can represent this as 4 groups of 6 visually. So I'm drawing the rate of matches. So there's 1 group of 6. There's 2 groups of 6. There's 3 groups of 6. And then finally, there's our 4 groups of 6. Okay, now what distributive property says we can do is we can actually take one of our factors here and we can actually break it into 2 numbers that make that factor. So for example, I can take 4, I can make it into 2 and a 2, because 2 plus 2 is 4. Now distributive property says I can then take this multiplication problem and rewrite it as 2 times 6, I'm pulling the 6 in here, plus 2 times 6. So I'm taking this this decomposed part of the factor, multiplying it by the 6. I'm taking this decomposed part of the factor and also multiplying by 6. And to find my product, I'm going to add those 2 products here, smaller products together. So we know that 4 times 6 is going to be 24. If we solve this, it's going to end up being 24. Okay, now, while the mathematical portion of it's all good and great, I think the best way to actually visualize and see this is we've got it through an array. Just to prove that we can actually do what we did here, break up your factor into 2 smaller parts and decompose into smaller parts, then rewrite it as 2 multiplication problems. So let's see if I can prove to you on the array that what I just did here could actually work. I'm take the red pen out, and I'm going to go ahead and circle the 2 groups of 6 I see. So this represents 2 groups of 6. That's my 2 times 6. And I'm going to go ahead and represent the 2 groups of 6 that's on the blue part of it here. This is my other 2 groups of 6. So to find my total number of objects here, I've got to add this section and this section together to find how much I have altogether. So altogether, this would equal 24. Okay, so let's go ahead and look at this using a different decomposition of the original factor. Let me backtrack a bit. And let's go ahead and change this from 2 and 2 to, I don't know, 1, sorry, my black now, to a 1 and a 3, because 1 plus 3 makes 4. According to the distributive property, I can rewrite this problem as 1 times 6. Sorry, let's color code it, make it easier to see. As 1 times 6 plus 3 groups of 6. And then my product should still be You get 6 plus 18 is 20. Okay, so let's go ahead and model this one on the array I built for 4 times 6. This would be one group of 6. And then this would be my 3 groups of 6. And to find my total product, I have to add these two sections together. Okay, now, not only can you break apart the first factor, but you can also apply the distributive property to the other factors in the problem. So I can actually take this problem, and instead of breaking it apart 4, I can break it apart 6. I could, for example, write it as a 4 into 2. Because 4 plus 2 is 6. So then my new multiplication problem would look like this. 4 times 4 plus 2. To go ahead and model this part of it, I'm going to take my array and flip it around so that I can show you that even though I've decomposed my 6 instead of my 4, the distributive property is still true. This will still equal. So 4 groups of 4 looks like this. There's 1, 2, 3, 4 groups of 4. And that would be 4 times 4. And 2 groups of 4 looks like this. And if you add 16 and 8, the product is still going to be 4. Okay, so that's the distributive property in a nutshell. Once again, it basically says that we can decompose one of our factors into 2 smaller parts and then create 2 smaller related multiplication problems that when added together, get you the same product. But once again, the best way to look at and learn it is by playing with the arrays you make to match your problem. That's the best way to see why distributive property actually works. All right, until next time, this has been Mr. Thill.